Hey guys, Miss Middleton here today. We're going to talk about CPCTC. Okay, fun to say. Um, at the end of this video, you should be able to explain when to use CPCTC in proofs, and I can use CPCTC to complete proofs. Alright, so how many congruent parts do we need to prove the triangles are congruent? Okay, in our 5 shortcut proofs, we found out that we need 3. We need 3 parts. Okay, how many parts are congruent in congruent triangles? 6. Remember, congruent triangles, if they're congruent, that means all angles on all sides are congruent to a corresponding part on the other triangle. So therefore, if we can prove 2 triangles are congruent with only 3 parts, and there are a total of 6 parts congruent, then that means that the remaining 3 parts are also congruent. And that's by the definition of what a congruent triangle is. Okay, that is leads us to our idea of CPCTC. Okay, and we'll use CPCTC, but it stands for, and you need to know this, corresponding parts of congruent triangles are congruent. Okay. CPCTC says if 2 triangles are congruent, then all of their corresponding parts are congruent. Okay, so notice, we're jumping straight into an example here. Notice what we're trying to prove here. I want you to prove that JK is congruent to NO. Okay, it's not marked for us. Now, this is already proven out for us, so we see we have LK congruent to MO, MN congruent to LJ, and then we have this included angle congruent. So why are these 2 triangles congruent? They're congruent by side, angle, side. And since the triangles are congruent, all the pieces in the triangles are also congruent. So, since JK and NO are corresponding parts, then we can say that JK is congruent to NO because of CPCTC. Okay, remember this. Corresponding parts of congruent triangles is only used after you prove 2 triangles congruent. You can't say, hey, those are the same because the triangles are congruent if you don't show that the triangles are congruent. Alright, let's jump into a proof here. We have to prove that AC is congruent to ED. So now, and they're talking about just parts, so I'm probably going to have to prove triangles congruent first. So AB is congruent to EB, that is given. They have another piece of given information, so I'm going to say that angle C is congruent to angle D. Again, marked for us already. Vertical angles. Okay, so I can see that these 2 angles are vertical. Anytime I really see that bow tie shape, I'm looking for vertical angles anyway. So I have angle ABC is congruent to angle EBD. Okay, remember that when we name those, we name them how we draw them without picking up our pencil, A to B to C. Okay, and then now with my markings, I can say that these 2 triangles are congruent to each other. I can say that CAB is congruent to DEB because of angle, angle, side. Okay, angle, angle, side because the side is not included, so it's not angle, side, angle. And now that I know that these 2 triangles are congruent to each other, then I can say, hey, AC is congruent to ED because corresponding parts of congruent triangles are congruent, or CPCTC. Okay? Alright, so that's CPCTC. That's one of the ways that we can use it. Let's go on and practice that in another proof. So here, we're proving that angle M is congruent to angle R. So again, we're not proving 2 triangles are congruent, I'm proving parts of triangles are congruent. So in my mind, I know I'm probably going to use CPCTC. I'm going to walk through this proof kind of in my head to see, okay, I got 2 sides on triangles. I got 3 sides because I share sides, so I can prove these 2 triangles by side, side, side. Then I can use CPCTC. Alright, so let's do that. So I'm going to start with my givens. They told me that OM is congruent to RE, or ER. I guess they're both the same thing. That's given. They told me that ME is congruent to RO. Okay, that's given. And we can see those markings with the 2 dashes means they're equal to each other, the 1 dash means they're equal to each other. And then we're going to figure out, or we figured out, that hey, this side's the same because it's the same side. So OE is congruent to OE, and that's the reflexive property. Reflexive property of equality. Just going to say the reflexive property. Okay, and so now with that, I can prove that these two triangles are the same by side, side, side. So triangle OME is congruent to triangle ERO by side, side, side. Remember, the order does matter here. And just to rehash this hint, I always go through the same dashes. So I went from 1 dash to 2 dashes. And in the next triangle, I went from 1 dash to 2 dashes. ERO, OME. Okay. This matters because if I'm going to say that M is congruent to R, they need to be corresponding parts. And our rule for naming our triangles is that corresponding parts have to be in the same spot. And so now I can say that angle M is congruent to angle R because they are corresponding parts in congruent triangles. And so they must be congruent, or CPCTC. Okay. So there are other ways that CPCTC can be used, and that makes the proofs a little bit tougher, but we can go through this and understand them too. So notice this proof that they're asking us to prove that ML is parallel to JK. Okay, so they're not asking us to prove that two parts are congruent. They're asking us to prove that ML is parallel to JK. Okay, and so let's go through it. They told us JM is congruent to LK, that was given. They told us that JK was congruent to LM, that's given. They told us that MK is congruent to KM. Well, that wasn't given, but we can see that that's because of the reflexive property. Okay, so very similar to this first proof here. Okay, and then triangle MJK is congruent to triangle KLM because of side, side, side. And then so we can say that JKM is congruent to LMK because of CPCTC. So now this is where CPCTC comes in. I'm going to mark this up for us really quick so we can see it. Oops, sorry guys. JKM, LMK. Okay, so this one shouldn't be marked. All right. Now they want us to prove that ML is parallel to JK. How can we do that? Well, notice where these angles are, here and here. Okay, a little bit of a refresher from last chapter, but these two angles are alternate interior angles. Okay, and since we're proving that two lines are parallel, then we can say these two have to be parallel because of the converse of alternate interior angles theorem, which says if our alternate interior angles are congruent, then our lines must be parallel. Okay, so does CPCTC always come as the last step in a proof? No. Does CPC directly prove lines are parallel? No, it did not directly prove it. We had to use CPCTC to show that the alternate interior angles were congruent, and then since the alternate interior angles were congruent, we could say the lines are parallel. All right, so we can use CPCTC to prove lines parallel. We can also use CPCTC to prove that that a segment is an angle bisector. Okay, and we're doing this more on our own. So they gave us that P is the midpoint of IO, so that means that these will be congruent. Okay, we have a shared side, so that's congruent, side, side, side. I can prove two triangles congruent. I need to prove that PS is the angle bisector of ISO. So ISO, I need to show that these two angles are the same, which I can, I think. And so then that will make it the bisector. All right, so let's do that. Start with the givens. I'll start with the drawn givens. They told us that IS was congruent to OS. That was given. In the given statement, they told us that P is the midpoint of IO. That's given, but I'm not done with that idea. Remember, I want to be able to have a marking after I've set a point. Okay, and so that will lead me to, since P is the midpoint of IO, I know that that means that these two segments have to be the same. So I know that IP is congruent to OP. And I know that because that's what a midpoint does. Definition of midpoint. Okay, and then I can say that SP is congruent to itself. It's congruent to SP. And that's reflexive property of equality. Again, very much like the other proofs back here. Make my mark. Okay. Alright, and now I'm ready for a congruent statement since I have, all my sides marked up and I have side, side, side. So my congruent statement, remember, go through the same pattern. I'm going to go SIP, so 1 hash to 2. So triangle SIP is congruent to triangle SOP, 1 hash to 2. Alright. And so since I know that, now I can say, okay, well, I need to see that these two triangles, or these two angles are corresponding. ISP, OSP, they are. Sweet. So angle ISP is congruent to angle OSP because of CPCTC, which I hope I've said enough for you guys to remember that it means corresponding parts of congruent triangles are congruent. And now that I know that these two angles are the same, then I can say, well, PS bisects angle ISO, and I know that because that's what a bisector is, definition of angle bisector. I just showed that those two angles have to be congruent, and so PS has to be bisecting those angles. Okay, you could also use CPCTC to prove a midpoint of a segment. And these aren't the only reasons that you would use CPCTC, but I want to show you that you can use that to kind of further your proof. Okay, more than just saying that two things are equal to each other. All right, that's CPCTC, using corresponding parts of congruent triangles. I will see you later.